Hey again, everybody. Here's another expert example that, it's probably one of the more annoying ones to have to try to do because it seems so simple in the beginning and then all of a sudden it gets really complicated really quickly. I mean, just looking at it, you can say, oh, I know, the 1 plus x squared is probably where I'm going to have the most issues, and this x to the fifth will probably just work itself out. By the way, that's not the fifth root. That's x to the fifth times the square root of 1 plus x squared. Okay, so if I let u equal the 1 plus x squared, this just seems to go pretty naturally into the same kind of thing we've had before. The problem is, obviously I don't have the 2, so let's take out the 2. That's a clear one. But the x dx is sort of here, right? I have the dx and I have an x, but it's x to the fifth. Okay, so I have to the fifth power. So if I split that up, if you look at that carefully, here I'll even do it like this: x to the fourth square root of 1 plus x squared times x dx. Right? That's the same thing, right? My x to the fourth times x is x to the fifth, but I wanted to make it real clear that there's my x dx. Okay, so I can take care of that. I can take care of the 1 plus x squared. The problem is I don't know how to take care of my x to the fourth. Okay, that's a mystery right now. And this is again where the little shenanigans comes in, the tomfoolery. The u equaling 1 plus x squared is crucial because you can do anything you want with that. If u equals 1 plus x squared, then doesn't x squared equal u minus 1? Right? Isn't that the same thing? Well, wouldn't that mean that x to the fourth equals u minus 1 squared? Right? If I just square both sides. And now I have an x to the fourth that can be substituted for. And that's really it. I mean, you just have to try to find a way to substitute your x's into u's, and that's one way to do it. So if I make a full substitution now, my x to the fourth becomes u minus 1 squared, my square root of 1 plus x squared becomes square root of u, and my x dx becomes 1/2 du. And I've now successfully substituted all my x's for u's. And even that right there isn't that easy to solve because I've got a square root, I've got something squared. I'm going to have to actually expand that. I really have no other choice. This is going to be u squared minus 2u plus 1 times square root of u times 1/2 du. Let's go ahead and multiply through by square root of u. So this is going to be u to the 3/2 minus 2u to the, not 3/2, 5/2. This is 3/2 plus u to the 1/2 times 1/2 du. So this is going to be 1/2 u to the 5/2 minus u to the 3/2 plus 1/2 u to the 1/2 du. And that's something we can actually just go piece by piece. So piece by piece, this turns into 1/2. Let's see, that's going to be u to the 7/2 over 7/2 minus u to the 5/2 over 5/2 plus 1/2 u to the 3/2 over 3/2. And it's indefinite, so I have a plus c. Clean that up a little bit. That's going to be 2/7, so that's going to be 1/7. Let's see, 2/14, I mean, so 1/7, so that's going to be u to the 7/2. That didn't change. This is going to be minus 2/5 u to the 5/2 plus, that's going to be 2/6, so 1/3 u to the 3/2 plus c. And u we said was 1 plus x squared. So this is now 1/7 1 plus x squared to the 7/2 minus 2/5 1 plus x squared to the 5/2 plus 1/3 1 plus x squared to the 3/2 plus c. And again, at this stage you might be saying, oh, why am I plugging back in now? On the last example, Mr. Miller said not to. Because this is indefinite, right? The original question wants me to integrate this. So my final answer should be in terms of x because my original answer is in terms of x. When you're doing a definite integral, you're finding a specific number, a specific value, a specific net area under that curve. So putting in the u's is okay because you're really just trying to solve a value anyway. Okay, so it's a little bit different. This is an actual function. Okay, in fact, this is actually a family of functions because of the plus c. It could be plus 5, plus 10, whatever it is, it's still a function. Okay, so hopefully, that's about as difficult as it's going to get. The only other issue people generally have is picking the u, right? Deciding what to let u equal, and sometimes that's just trial and error. So, you just kind of have to play around with them and figure out which u makes the most sense. In my opinion, when you're doing this, pick the u that's causing the most trouble. Okay, once you figure out which u is causing the most trouble, start there. And there are some examples where you can pick a u value and it ends up working, multiple ways. Like you can pick a different u value and still get the same answer. But I'm going to let you figure that out based on the examples that I assigned and see how that goes for you, okay? Let me know if you need any help. I think this is pretty much all you need to get the meat and potatoes of it. But if you're looking to get dessert, let me know and I'll scoop you some ice cream. Whatever the heck that means. I have no idea what I'm talking about. Okay? I'll talk to you later. Bye.